Okay, so again, very similar to your free response question on your test on Wednesday, but your question on Wednesday will be a little bit trickier on the phase shift. Not difficult, but these were all easy phase shifts, which means we just picked them up and moved them by some number of critical values. So the original marks were the final marks. All right, so let's do number one. I already wrote it here. I'll just copy and paste it down here. And then we're gonna emphasize notation as much as possible, okay? Because things that I would deduct for on a free response, I'll emphasize here. Step one says to put it into standard transformation form. Is this one already in standard transformation form? No, you got the inside where you have the B value distributed to both terms. And so if you didn't factor out the 2 from both of these, you'll get your phase shift wrong. So whenever you're rewriting it, make sure it's still an equation, not an expression. So we'll factor out the 2. And remember, factoring out of 2 is the same as dividing out of 2. And dividing by 2 is the same as multiplying by 1/2. Yeah. So if you factor out a 2, all you have to do is multiply the other term by 1/2. What's pi halves times 1/2? Pi fourths. Close, close, minus 2. So now we need the extra parentheses. And how do you know if it's right or not? What can you quickly do before you proceed? Mentally redistribute. 2 times x is 2x. 2 times negative pi fourths is negative 2 pi fourths. Negative pi halves. We're good. No, not today. But put it, because you will lose points on the test.
If we just put equal sign like underneath it.
Right. If you're working straight down like that, that's fine. But most of y'all probably just went part A, and you just have an expression. On the test, that would lose points, because that's not an equation. Okay? So very, very important. Little things. Oh, yeah. Good question. Let's A. I better start giving you checks. We'll have a check for that. Okay, there's check number 1. For having 2 times x minus pi fourths. There's the first check. Okay. Letter B. Letter B says how many cycles? Yeah, first let me address something. If I ask you on a test what the amplitude is, what is the amplitude of this function? It's the absolute value of A, which is positive 2. You cannot have a negative amplitude, okay? Did y'all hear that? Your amplitude, like your reference angle, cannot be negative. It's always a positive number, because it's the positive distance that you go above and below the sinusoidal axis. Now, your A could be negative, but the amplitude cannot. All right, so I'm just going to put that. The amplitude is 2, and because it's negative, I'm going to put a reminder to flip it. Now, I didn't ask you for that, so what I asked you for was how many cycles do we have from 0 to 2 pi? That is the absolute value of B, which is what in this case? 2. So we have 2 cycles in 2 pi. So that'll be check number 2. That's fine. The reason on part B you can just put 2 is because I only asked one thing on part B. I just said, how many cycles in 2 pi? 2 would be the answer. On the test, I sometimes ask 2 different things on one letter. So if I ask you, like on part B, what is the amplitude? Question mark. What is the period? Question mark. Now you better label. Okay, but if you only ask one thing on per question, then it's implied that you're answering that question specifically. So, no, you could just put. Yeah, I mean that's probably the best way to list it because it's all right there together. But if you just put 2, you're fine. 2 cycles in 2 pi. So it is 2 cycles between 0 and 2 pi, but it could also be 2 cycles between pi halves and 3 pi halves, or I'm sorry, pi halves and 5 pi halves. So in any span of 2 pi. It doesn't have to be from 0 to 2 pi. In any span of 2 pi, you're going to see 2 complete cycles. So the answer in this case is just 2. All right, letter C, what's the period? All right, so the period is affected by B. The period P is always 2 pi over the absolute value of B, which in this case is 2 pi over 2, which turns out to be pi. So again, you could just answer it as pi. Now it's preferred that you label it P equals because that has more meaning now. But if you didn't, that's fine. It specifically asks you, what is the period? The period is pi. Pi what? What are the units on pi? Radians. Yeah, nothing. Okay, good. Letter D, what's the range? So before we sketch it, we can find the range. Remember the range, you want to write it like this. The function's name is f. So the way that we've been doing it all year is R subscript the function's name. That's the best way to do it. So on the test, I'll be looking for that. But today, if you don't have it, that's fine. In general, it's D minus the absolute value of A for your lower bound and D plus the absolute value of A for your upper bound. Now, you don't have to write that, but that's what the formula is. And so it's going to be, what's our D value? -2. So we're going to go -2 and then down 2, and then -2 and up 2. So the range for this is going to end up being -4 to 0. And we'll call that check number 4. So that's the easiest way to do it with interval notation. And again, I'm kind of just working straight down here. Or, of course, you could say it's the set of all y's such that -4 less than or equal to y less than or equal to 0. Because when you're doing a compound inequality, it's always least to greatest, and it's always less than or equal to. Right, Jenna? Tyler? We were having the conversation with my daughter at the kitchen table yesterday about that. She had it written like this. We weren't doing this problem, but something similar. And I was like, ah! And she goes, why? The alligators are eating the right thing. And I'm like, that's just bad. So anyway, we had that conversation. That's just bad. That's just bad. Okay, A, B, C, D. What comes next? E. Sketch at least 2 full cycles with at least 1 negative critical value. And that's going to be kind of the standard. All right, so now we can put it all together. And our range is entirely negative or non-positive. So when you're making your marks, there's the y-axis. I can make my x-axis a little bit taller. Okay? Now, because these are easy phase shifts, we don't need the sacrificial axis. But if you don't know, like in the future, you're not going to know, it's always a good idea to make that little rough draft x-axis first. Okay? But in this case, all of them are going to be picked up and set back down in the same marks, so we can just go ahead and go straight to the final graph. The period is pi, so remember the easiest way to do it is to come out about 3/4 of the way right there. Oops. And it's an arbitrary distance. Call that pi. That is the period. Okay? Since you need 5 critical values or 4 intervals, you could bisect that and then call that half of whatever that is, and bisect it one more time, and you get pi-4. So pi-4 is the most important value on this graph. It's the quarter cycle counting interval. And now, because 0 is one of them, the distance from 0 to pi-4, whatever it is on your paper, is what you try to preserve in between each and every subsequent critical value. So you're going to have to bisect that one more time, and then you just throw down however many points you have room for. In order to sketch 2 complete full cycles, you need how many? 10 would actually be a cycle and a quarter. You actually only need 9 critical values. Because the first one is the 5th, but it's the last one of the first is also the first one of the next. So you really only need 9 critical values. That's good to know. If you have more than 9, is that okay? Sure, because it says at least. So how many do I have? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I done? No, I need at least 1 negative one. So I have room for more than 1, so I like going above and beyond, or in this case, to the left and beyond. So 1 pi-4, 2 pi-4, 3 pi-4, 4 pi-4, 5 pi-4. I do want you to simplify as you go. You will lose points if you don't have your x-axis simplified. 6 pi-4 simplifies to 3 pi-halves. 7 pi-4. 8 pi-4 is 2 pi. And then over here, I got negative pi-4. Negative 2 pi-4 is negative pi-halves. All right, so now let's think about where our new y-axis went. Of course, our old y-axis was on the y-axis, hence the name. And we picked everything up and moved it what? Pi-4. Right pi-4. So pi-4 is your new y-axis. So a dotted line or a dashed line, whatever you want to do. There's your new y-axis, which by the Sahala-Chala method, that's where we have to start now. All right, so now we pretty up the y-axis, and the range is -4 to 0. So 0 is our high point. And if you want to do this, just kind of come down here and call that -4. And then it's easy to put your sinusoidal axis in place because it should be where in relation to 0 and -4? Right in the middle. So you just bisect that distance, and you call that whatever the d value is, -2, and then you draw your horizontal line. Now, if you don't want to do it that way, that's fine, but as soon as you put your sinusoidal axis, as soon as you have 2 points, the scale is set, right? So whether or not you preserve the distance from 0 to -2 and you double that to go low, or you do what I did, high and low, and then cut it in half. And that's it. We are now ready to accommodate either a sine or a cosine graph. Ours ended up being what? A negative cosine. A negative cosine. So again, cosine is chala, right? Which normally starts high. All a negative does means is now we're starting what? Low, okay? So I'm going to pick a flavor here. I like pink bubble gum. And we're going to then go to our new y-axis, which is at pi/4, and because it's negative cosine, we're going to start low, so boom, right there. And once you have either a high or a low point, the rest of the points are set in motion, right? So we'll just go to the right then. The next point would be an axis, and then a high, and then an axis, and then a low, and then an axis, and a high, and then an axis. And then if I go back to the left, 0 is a critical value. So we're on the axis right there, and then a high, and then an axis. And now all we have to do is connect the dots with a nice, smooth, make sure that they pass the vertical line test, don't get extra wiggly, and try not to make them V's at the local max and mins. And then extend it past wherever you are, or turn the corner, and you have your graph, okay? And it should look very sinusoidal, very periodic. So for all of that, yes, all of that, I'm going to give you just one check, just to make it easy, okay? If you have a graph, we'll be generous on the graph. If you have a sinusoidal graph, if you graph the log function, don't give yourself the check, okay? If you have the wrong graph, you're probably going to miss the next part, okay, which is coming up with the other equations. But you can get the graph check even if it's the wrong graph.
Wait, if it's a graph?
If it's a graph, yeah. A sinusoid graph. Yeah. Again, if you sketched x squared, no check. Like, I know how to sketch x squared. I'm just going to stick with that each and every time. All right. Write at least an equivalent equation in terms of each of the other 3 trig functions. So what do I mean by that? Well, we started with the negative cosine, so the other 3 that are left are positive cosine, positive sine, negative sine. Okay, that completes the set. All right, so if we're going to do that, everything except the phase shift and possibly the sign in the front are going to be the same. So go to your first check, your standard transformation form, and use that as your template. All right, so, and then I'll clean this up because there's more stuff there. So what I'm going to do is get rid of the negative, get rid of the cosine, and get rid of the phase shift. And everything else should be the same. So if we had a negative cosine to start with, let's go ahead and do the next one, which will be a positive cosine. Now this is the one I actually want to copy. And I'll switch flavors to show the change here. So a positive cosine, what do I put in front of the 2? Nothing, right? If you want to put a plus sign for emphasis, that's fine, but you don't need anything. Just have the awkward space there. That's good. And then put the cosine in there. And now here's all we have to do. Positive cosine starts at what position? At a high point. That's it. It's chala. The first letter after C in cosine is H. We have 3 high points showing. All we have to do is get over to any one of them. So you can either have plus pi/4, or you can have minus 3 pi/4, or you can have minus 7 pi/4. I'll take any one of those. And there are how many others? Infinitely many. Yeah. Okay, so we'll call that the 6th check. All right, so now we have a couple of signs to go. Let's do the signs. So I'll paste that again. And let's do a positive sign first. So again, in front of the 2, it's a plus sign. Positive sign, you always look for 2 points, because sign always starts on an axis, sahala, S-A. So for a positive sign, we need to be on an axis going up. Positive is always up or going up. Negative is always down or going down. So where are we on the axis going up? Negative pi halves, positive pi halves, 3 pi halves, yeah. So you could actually have plus pi halves, minus pi halves, minus 3 pi halves. Any of those would work for the 7th check. All right, and then the last one, I'll throw it over here. And notice each time I do have f of x there, don't I? So don't count off today if you don't have that, but on the test you will lose points if I ask you to write an equation and you don't have an equation. All right, so negative sign is the last one we need. So now I'll put the negative in front of the 2, negative sign. And negative sign, we're looking for a place on the axis that is going down, right? Instead of axis high, it's axis low. So it could be 0, pi, or 2 pi. So I'll do this one first. It could be minus pi, minus 2 pi, or it could be this, negative 2 sine of 2x minus 2. Okay, you wouldn't need a phase shift. That's fine. Just make sure you close the parentheses again. Yeah, for every parenthesis you have open in the interior, you need a closed one. So if you left it with an open parenthesis there, then you need to close it as well. And it's good to keep your angle closed off in parentheses from the d value. It's not entirely necessary, but it just looks better. All right? So that would be check number 8. All right, questions on number 1. Kind of fun? Yeah, kind of. They do get more fun. All right, letter B, or number 2. I'll copy that one. We'll slide down here, paste it. Number 2. All right, part A, is this in standard transformation form? Yeah, it actually is. So, freebie. Check number 9. Yeah, yay. Already in standard transformation form. Yay. Cool. All right, so part B, I asked you for the number of cycles in 2 pi, which is what? 1. 1 cycle in 2 pi. Or, as Zane would probably just put, 1. Just answered it directly. Okay, 1 like that, or just a straight line, or O-N-E. Cycle. Yeah, there you go. Part C, what is the period? Yeah, it's 2 pi over B or 2 pi over 1. It's 2 pi. There's the 11th check. It's an easy. For boring, maybe. It's kind of boring so far. Letter D was what? The range. Okay, the range. Finally, something interesting. What's the name of our function? G. Yeah. Close to R. It's in the same alphabet. Big R is what you meant, right? Sub G. And let's see. Our D value is -6, and our amplitude is 5. So it should be -6 minus 5 and -6 plus 5, which of course then simplifies to -11 to -1. We'll call that check number 12. So most of our values are negative. Well, all of them are actually. Most of them. In fact, all of them, yeah. Okay, good. Way to go. Yeah. Nope. You don't have to. If you just want to show that, that's okay. And then the fun part. The whole reason we're doing this is to sketch it. Yeah. Now, again, if you're not sure, because we do have, there's a phase shift of pi halves what? Left pi halves. If you're not sure if you're going to have to make new marks, eventually, a rough draft x-axis would be helpful, but these are all easy. So let's just go straight to our graph. We need a y-axis. There it is. And we need an x-axis. There it is. And now we'll put the points on there. So again, somewhere right in there, is 2 pi. Is that what I do? I'm losing track of what I'm supposed to be doing. Is that right? Yeah, that's the period, right? So whatever the period is, it's going to change per problem. You always go out the period length, not always 2 pi. Then you bisect it once to get your half cycle, bisect it again to get your quarter cycle, and again, pi halves now is the most important number. That's the distance between all of your critical values. So remember, 0 is still one of them, helps to label it, and then keep those points kind of the same, and I'll just come over here and put 2 points. And I need at least how many for 2 cycles? 9. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go.
So how do you determine how far you bisect? Is it just determine the number of critical values you need? Is that all you're
You bisect it for a couple of reasons. You bisect it once and then twice to get your quarter cycle. When you cut something in half twice, you take a quarter of it, okay, which gives us our quarter cycle counting interval. But it also helps you, wherever you put your original 2 pi mark, it could be farther away from the y-axis or closer. It doesn't matter. But when you cut it in half and cut it in half again, you are now establishing on your paper, on your graph, the distance that you're going to refer to consistently as the quarter cycle interval. And that's what I'm going to be looking for. I'm going to be looking at your paper and seeing if the distance between each of your critical values is roughly the same. And it might be different from your neighbors, and that's fine. So that's why you come out an arbitrary distance and then cut it in half and cut it in half. It's just an easy way to bless you or measure. Yes, Tyler?
Why would it be 5 critical values? Because it's 1 cycle.
5 critical values are needed for 1 cycle.
Right.
9 are needed for 2. No, I'm asking you to sketch 2 cycles. Yeah, from 0 to 2 pi is 1 cycle. But I need at least 4 more critical values for another cycle, which is why we sketched 9. So remember, the last critical value of the first cycle is the first critical value of the next cycle. So that's why you don't need 10. At least 9 critical values with at least 1 negative critical value, always. Yeah, and I'll say that in all the future instructions as well on tests or quizzes. All right, so now we have to label everything. I do want you to label and simplify. 1 pi halves, 2 pi halves, that would be 3 pi halves, 4 pi halves, 5 pi halves. What is 6 pi halves? 3 pi. 6 pi halves is 3 pi, and then 7 pi halves. And then going left, negative 1 pi halves, negative 2 pi halves is negative pi. And then we've put our new y-axis. We shifted everything what, pi halves? Left. So the old y-axis was on the y-axis, and now we move everything left. Turns out, just 1 tick mark. So there's our new y-axis. Look how straight that is. Okay. Now for the other values. I'm going to call that negative 1. And I'm going to do that just so I can clear my numbers. It's nice if you don't have to like go in the middle of your numbers. Now I will be pretty lenient here if you then just call that negative 11. Now I notice that that is not drawn to scale because I'm calling this distance here 1 unit and that distance 10 units. But that's okay so long as the distance in between them you bisect and call that your sinusoidal axis. Okay, because we're trying to graph these things so that they look pretty. And what number is that? Negative 6. All right, so I do want you to label that. So everything that you see labeled here is exactly what I'd want you to label on your paper. Okay, you have all the critical values labeled, at least 9, and 1 in negative land. You have your high point, your low point, and your sinusoidal axis labeled. Anything more than that, you're going to lose points, unless it happens to be another critical value. Yeah.
Do you want us to draw our dotted new axis?
Sure. Yeah. Yeah. I mean, it can be really, really faint, but it does help you. I probably wouldn't count off if you don't show it, as long as your graph is correct. So if you've already been kind of like mentally graphing them, then that's fine. They're really not there, right? That's why they're dotted. All right, so now we put our dots. This is a positive sign. So positive sign is Sahala. So we go to our new y-axis, and we start on the axis, right? But remember, there's 2 places to go from the axis. We need to go axis high. So that's going to be there. Axis low, axis high, axis low, axis. And then working to the left, we have one more. I have one more. There it is. And now we connect the dots, which is the fun part. Wow, these are very prominent inflection values. And critical values, sorry. And remember, you want to turn the corner or extend out past for your last one. So once again, we'll give the 13th check for any sinusoidal graph. Any sinusoidal graph. If you graph the absolute value of x function, no check. And make sure it does pass the vertical line test. Right? Don't get extra curvy. So from there, we need to write 3 more equations. So I'm going to circle that, copy it, and then jump down here and paste. And what's going to change? Well, possibly the sign of the amplitude and, of course, the phase shift. So I'm going to make a little bit more room here by scooting that over. So if we started with a positive sign, let's go ahead and do the negative sign first. So -5 sine, and now all we have to do is find the phase shift. Negative sign, what are we looking for? Axis going down. Axis going down could be pi halves to the right or 5 pi halves. That's what I have labeled there. So it would be either minus pi halves or minus 5 pi halves. That'll be check number 14. Paste the next one. Oops. I got to do more work here. All right, so which one do y'all want to do next? We have 2 cosines to go, a positive or a negative. You want to go negative first. That way we end on a positive. I love it. Beautiful, beautiful idea. All right, so a negative cosine. So now we have a negative a value. Cosine looks, negative cosine, we're looking for a low point. We have 3 of them shown. So either plus pi, that moves it left, or minus pi or minus 3 pi. So plus pi, minus pi, or minus 3 pi. Any one of those in there could be the 15th check. And then finally, we'll do a positive cosine. So you either leave the awkward space there, you put a plus sign or a 1, or you scoot the g of x in, it doesn't matter. And now we're looking for a what? A high point. We have 2 high points showing. One at 0, which is nice because it requires no phase shift. One at 2 pi. So it could be minus 2 pi, or it could just be 5 cosine of x minus 6. So again, you wouldn't need parentheses around the x, because we would assume then the minus 6 would be the next term, but to have them is kind of nice. So that would be the 16th check. You could also have minus 4 pi, minus 48 pi. All right, you getting the hang of it? So far, so good? So fun, it's almost boring. Is that really a thing? No. All right, number 3. Number 3, h of x. Notice all 3 of these had different names. Let's use green for this one. Number 3. All right, part A. Put it into standard transformation form. Is this one in standard transformation form? No. This one requires a couple things. The 3 in the front really should go where? To the back. Get the back. All right. So it's a -4 sine. Now, if you notice on the inside, there's 2 things that we need to do. And if you could do them in one step, great. Just don't mess up. We have to have the x term first. So I'm just going to take baby steps to do that. So I commuted those 2 terms. Now I have my plus 3 at the back. But now on the inside, I have to factor out a what? A 4 in order to get my phase shift correct. So extra parentheses, x plus. Now again, when you factor out a 4, you are dividing out a 4. And dividing by 4 is the same as multiplying by 1/4. Okay? So what is 3 pi halves times 1/4? 3 pi eighths. Good. Close, close, plus 3. And then quickly mentally redistribute. 4 times x is 4x. 4 times 3 pi eighths is 12 pi eighths, which is 3 pi halves. Sweet. So now we're ready to go. Let's give ourselves a check for that. And we're ready for part B. How many cycles do we see between 0 and 2 pi? Oh, it is. Oh, yeah, 15, 15. I've never been good at numbers. My bad. Thank you. Okay, sweet. 17. How many cycles in 2 pi? 4. Check. Oh, you did? Okay. 4 cycles in 2 pi. If you're going to put 4 cycles, you probably should then put 4 cycles in 2 pi. But anyway, 4 is okay. Because I only asked one question here. Part C. What is the, what was I forgot. You think I'd know. Period, yeah. Which is also known as the wavelength. What is the period? In general, P is 2 pi over the absolute value of B. B is 4. So 2 pi fourths simplifies to pi halves. Let's check number 19. Hey, what if on the test I happen to ask you for the frequency? It's the reciprocal of that. What's the reciprocal of pi halves? 2 pi, right? 2 over pi. 2 over pi. Good. The frequency is the reciprocal of period. So just an FYI, just a reminder. And then part D, the range. Yeah, that's it, the range. So R sub H, again, should be D minus the absolute value of A, D plus the absolute value of A. And let's see, for us, the D value is 3, and the amplitude was what? 4, not negative 4. Good. So it's going to be 3 minus 4 for the lower bound, 3 plus 4 for the upper bound. That puts us from -1 to 7. And that's check number 19, 2, or 20. We'll just call it 20. We won't use 19 twice. And now we're ready for the graph. So notice here, most of our y values are positive. So when we're sketching the graph, of course, we'll need a y-axis. And now most of them are positive, so I'm going to draw it like that. I don't care for that one. I got to move this guy over. Picky, picky. There we go. Looks good. All right, so again, we don't know if there's going to be new values required, bless you, in general. So when in doubt, make a little rough graph axis. But this one is the easy phase shifts. So we can just go out the period length, which is what? Pi halves. Pi halves. So we'll come out here, pi halves, right there. Half of that is pi fourths. Half of pi fourths is pi eighths. Now, you could get the quarter cycle counting interval without bisecting. You could just take a fourth of pi halves, which is pi eighths. But by bisecting it now, you get this distance right here, from here to here, which you want to preserve. So now it's that, and that, and I'll come left once, twice, 3 times a lady. There we go. And we'll just label it. That's 0, 1 pi eighths, 2 pi eighths, 3 pi eighths, 4 pi eighths, 5 pi eighths, 6 pi eighths is what? 3 pi halves? 6 pi eighths? Is that right? 3 pi fourths, yeah. Yep. 3 pi fourths, 6 pi eighths, 7 pi eighths. It's okay. If you need to do that off to the side, it's a good place to do it. -1 pi eighths, -2 pi eighths is negative pi fourths, -3 pi eighths, -4 pi eighths, blah, 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 blah. All right. So let's get the new y-axis. We're shifting everything, what? 3 pi eighths left. So now would be the time, if you only had negative pi eighths sketched, because you only required to have one, in order to shift it left and see that, you would probably now volunteer on your own to add more critical values to the left. And there's 3 of them. You need 3 of them. So there is our new y-axis. So there's some dots. Okay. Now we'll get the y-axis all in order, -1 to 7. So I'm just going to call this value down here -1. And then 7, I'm going to call this 7. Might as well use the space. So if you label your high and low, then physically, just somewhere in between there, halfway, boom, roughly halfway, you stay right there, right there. That'll work. You draw the dotted line. What number is that? 3. How could you find that value if you didn't know the D value, but you just knew the high and low? How do you find the midpoint of any two numbers? Add them together and divide by 2. It's their average. 7 plus -1 is what? 6. Half of 6? 3. There you go. So now this is ready to accommodate both a sine and a cosine, either one. And we happen to want to accommodate a what? Negative sine, okay? So we go to our new y-axis. Sine always starts on the axis, so there's the first point. But now we need to go axis what? Low. That's finding the right size for the dots. That's always the hardest part. Okay, so axis low. So low is going to be down here at -pi4, -1. And the next point at pi8, -pi8 is an axis. Sorry, 3. I just defaced you. Is 0 a critical value? Yes. Okay, so we're hitting 0 each and every time. And you'll see in the future that's not necessarily going to be the case. And I probably have more than I need here. But it's better to have them and not need them than to need them and not have them. All right, so now we connect the dots. Oops, that didn't look good. Mine's pretty narrow. The closer together you make your points, as you probably figured out, the kind of more challenging it is to draw them, still make them look curvy, and still make them pass the vertical line test. So if you have the space, it's best to kind of use it and spread out. Okay, so there it is. Once again, if you have a graph of a sinusoid, if you drew just a tree, that's not a graph of a sinusoid, but it's probably pretty lovely, I imagine. But you don't get the 21st check. All right, so now the fun part. This is the fun part. Let's go ahead up here and copy this plumb equation. We'll slide down here. And let's get rid of some of that stuff. Ooh, that's the wrong one. That's why you're laughing. I was wondering why you were laughing. You were laughing at me, not with me, I hope. All right. Okay, so -4 sine. So let's go ahead and get rid of the negative, the sine, and the phase shift. And let's go ahead and write the other 3. If we have a negative sign, we need a positive sign. Let's get that one out of the way. So that's not a contrasting enough color. Purple. There you go. Mardi Gras flavors. And now for positive sign, we need to be on an axis going up. So that could be plus pi8. It could be -3 pi8. It could be even -7 pi8. And there's infinitely many more. We'll call that check number 22. All right. The next one. Let's do a negative cosine, since I already have the negative there that I just erased. A negative cosine. Negative cosine, we're looking for a low point, which is at -pi4, pi4, 3 pi4. So it could be plus pi4, minus pi4, -3 pi4. Any one of those would work. Let's check number 23. And then finally, the last one here, we'll do a positive cosine. Positive cosine looks for a high point, which could be 0 or pi halves. So if I have the minus pi halves, that works, or just 4 cosine of 4x with no phase shift plus 3, and that's check number 24. Yay, so 24 checks. That comes out to be how many points apiece? If they're full credit. Like 4? A poi? Yeah, 4 point something. 3 point? 4 point something. But we should do a discount, right? We should do 3 points apiece. Okay, 3 points apiece. So, we will stop right there. If you want to keep your paper, that's fine. You could just write it on a smaller sheet of paper and turn it in. All I need is your grade. But if you don't mind turning it in, just turn it in. Some people might want to keep it to study. I will give these back to you tomorrow, though. So put your name on it if you are going to turn it in.